Hello world, this is JWP, J Ward Primo Beats, coming to you live from my bedroom. Check out my website, jwpsite.com, for my social links, latest news and updates, and public offerings. If you'd like to help support what I do, check out my Patreon, JWP Patreon. That's with 2 P's. There's exclusive content there for making your own audio plugins in SynthEdit, as well as the presets for this SynthEdit series, or my GoFundMe, JWP Fund. If you're watching this on YouTube, a like, comment, and or subscribe are appreciated. I will be continuing to look at the Visual VSTi programming book. We are now on to the phaser. Phasers are like flangers, the main difference being that all pass rather than comb filters carve notches and peaks into the spectrum. Though built-in and third-party all-pass filters are available, SynthEdit's constraints preclude real feedback. The good news is that third-party phaser modules or other filter types can simulate phasers, peaks, and notches. Phaser Variation 1. Our first version employs all-pass filters. Rather than changing the frequency spectrum, all-pass filters distort the incoming signal phase. Take, for example, a sine wave. Applying an all-pass filter to it yields a sine wave of the same amplitude, but with a different phase determined by the sine wave's frequency. Different frequencies phases shift differently. Let me try that again. Different frequencies phases shift differently. Different frequencies phases shift differently. So how do we notch the frequency spectrum if it remains unchanged? By mixing the wet and dry signal. Frequencies with opposite phase cancel each other out, cutting notches into the spectrum. The number of all-pass filters in the chain determine the number of notches. The first example features a third-party module, EVM all-pass. On the upside, it does not hog as much CPU as the built-in all-pass filter. On the downside, it produces aliasing noise when modulated too fast because it updates the filter coefficients less frequently. It will do for standard phase modulation rates, though a dual stage phaser unit looks something like the setup in figure 2.66. The signal passes through the 2 serial all-pass filters and then mixes with the original signal. So we look at figure 2.66, we see an in-out mod. In-out. Now we have on the left the input, and it's going straight out, so it's parallel, and a pitch input, which is passing to 2 EVM all passes to the pitches. The signal input is going into the first all pass, and then that all pass is passing the signal to a second all pass, making them in serial, as it was mentioning. Too zoomed in here. Let me get zoomed out. Okay, that's chorus section. How do I zoom here? There we go. So it's chorus phase. And did it move to the next page? Yeah, okay, so it's still talking about the first variation. Oh no, that's just the end of the page there. Okay, so on to the next page. Let's zoom all the way out. For a second there, I thought maybe there was an error and there's a duplicate page, however. We created similar containers with 2, 4, 6, and 8 serial all-pass filters to enable stage selection. A one-to-many switch selects the number of stages. Figure 2.67 shows this structure. So we see figure 2.67 selecting stages using a switch. So we have the sort of the same thing as the previous version. However, we now have a switch in the middle, and we have phaser 2, 4, 6, 8, and those are all heading to the output. And of course, that's just one input, right? So that makes them one mono. Figure 2.68 outlines the main structure with 2 LFOs and controls. Much like those in the previous prefabs, a center knob with a 0 to 5 volt range selects the center frequency. The 2 LFOs modulate the all-pass filter's pitch, creating a sweeping effect. So figure 2.68, we now have controls. We see oscillators. It looks like this is probably the inside of the, it says figure 2.68, the phasers prefabs main container. 2 oscillators with rate and phase. Phase is only connected to the bottom one. Knob. Depth and center for connecting to level adjusts, which in turn connect out to 2 channels. Not sure what's in the channel boxes, likely the phase things. And then list entry, so we have a number of stages, and then those all pass out. Again, this we're still looking at, oh no, we're looking at a stereo version now. Heads up, swap the channel 1 and 2 containers for EVM phaser modules if you wish. They offer all pass filters and let you select stages and control other parameters. See phaser 2 to learn more. So I'm not sure if I'm supposed to get started now. Let's continue on. Yeah, let's get started actually, because it's moving on to variation 2. So I'm going to jump into FL Studio here, or SynthEdit rather. And this is the previous section. This is the course. What I'm going to do is I'm going to pull out the course components here, and then we have a framework to work with. We also retain the preset manager, so I don't have to rebuild that. I'll just pull everything. Oops, I didn't want to pull the in and out. Okay, so we'll just use this IO mod here, and we'll bring in another IO mod over here. It looks like we still have 2. Okay, we want to keep those. Those are for our selection down the road here. Okay, so phaser 1, go to files, phaser 1, phaser 1. Okay, so there's an error. There's 2 phaser 1s. So let's go ahead and open SynthEdit 1. Check out these prefabs. File, just go to the destination. And hopefully it'll let me open from there. I don't think it, no, it didn't. So I'm gonna have to save as, and that'll give me the destination of the folder here, and I'll copy that. Just so I'm not digging around the computer, and then I'll open my last save. Destination will open this destination, and we'll grab phaser. So phaser 1. Okay, so related to the images we've seen earlier, these are our components here. And of course, inside there we have, well, I can't look because it's locked, so look, 2 EV all pass filters with pitch. So I wonder what the range for that is, EVM all pass filter. So let's see, pitch, center. Okay, so it's giving us a percent, 0 to 100%, and it said in the book 0 to 5, right? So what does this say again? Center. Okay, so we don't have EVM all pass. It is depreciated. We do have our own all pass, and as it said that it's not sure why they're using the EVM. On the upside, it does not hog as much CPU as the built-in all pass. On the downside, it produces aliasing. Okay. So it's a little bit more greedy. However, this is a newer version of SynthEdit, so I imagine it might have been updated a little bit. I'm not sure. But we're going to be using that one. Okay. So let's take that and we'll duplicate it. We'll pass it on to itself. I'm just going to containerize that, these 2 here. We'll head in there. We'll name this container. What is this container called? Called phaser 2? Yeah. Okay, so this is phaser 2 container. And phaser 2. Oops. At phaser 2. Like that. Okay, and then I require input and pitch. So input first, then pitch, and then it just goes straight out. And pitch also connects to the second one here. And resonance is 5. Is it supposed to be 5? What's resonance here? Again, it's locked. Let's unlock it. Automation? Nope. Properties. 5. Okay. So generally that's like the Q, or what's it called? Resonance, right? Resonance, or what is it called? Resonance, right? Yeah, well, it says resonance. Okay, so that stays 5. Pitch gets overridden. Signal in, everything looks okay. So this is phaser 2. Okay. So that's pretty much ready to go. And then I imagine the preceding ones are just more in line, right? Yes. Okay, so let's go ahead and build those. So that's 4 and 6 and 8. So we'll cut this off and inject these here. And again, we want to bring in pitch. Okay. That looks good. And then the next one is 6. We'll name this 4 first before moving on. Same thing, however, this time we're going for 6. And I'm not going to follow the prefab exactly. I'm going to put them in line visually, opposed to starting to stack underneath. And these two are already connected by 2s. Pitch signal in. And pitch signal out. Is that what it's called in the prefab output? Yeah. Okay, so that's phase 6. And this is phase 8. So we can probably just copy phase 4 and double the internal modules. Save a bit of time. And if we really wanted to save time, I'm not sure if it's less clicks, we can go containerize and copy that, and then we can connect pitch itself and signal out here and output there. So I guess it does save time. And then what we do is we uncontainerize this. Then we got to break this link and uncontainerize that. And then pitch is already connected to them all, and they're already connected to the serial chain, and it's ready to go. So now we have phaser 8. And we want a one-to-many. So flow control, one-to-many. Drop that there. We want the signals. Oops, yeah, that's right. And then what are we calling these? 2, 4, 6, 8. Remember to hit enter. Oops, not until I put the number in yet. So we'll update that. And then this gets containerized itself. Containerize. And what's this one called? This one's called channel 1. I'll bring in the connections here. What's the order? Looks like input, pitch, output stages. However, we're going to go input, pitch, and then stages output. Just because I want all of the pins, all the input pins beside each other. Because, yeah, that's the way I do things. Okay, I'm going to name this. This is called stages, right? Stages. Excuse me. Stages, get pitch. Pitch. That's channel 1. Now we'll copy it over as channel 2. So from there, we want our inputs running in, and that's just straight out, right? Nothing in the way. Yep, level 80J. There's no like mix or anything, so looks like they're just going straight out. And these are LFOs. Again, that probably be best redesigned, as that's inefficient, that style. I'll look at that later. Off stream, if I'm going to build them, you know, for my own use. The preset will be as is, though. So something to consider is making those more efficient, as these will never sleep, as far as I know. Okay, so now we have rate and phase, which we already have, I do believe. So rate and phase is here. That's phase mod, right? Yeah. And the audio out goes to level 80Js. And that's under modifiers. Level 80J, two of them. And this one goes, looks like on the top. Yep. Okay. So tops. And then what's going on the bottom is these controls, right? Okay, so JIT's depth. Okay. So do we have a depth? We do. So let's go to the bottoms. Depth of the bottoms. Oh, and I just connected it to itself. It doesn't matter. This is just a prefab. Okay. Yeah. And then center goes to the pitches. So we'll change our min here to center. What is the readout here percentage? So we need another percentage. It looks like dry wet. We'll do, I don't know why I copied it. I might as well just use it. We'll call it center. And we'll pop in there, make sure there's nothing being adjusted here. And there is. So what we're going to do is we're going to pull all this. Do we want to keep float to volts smoothing? No, I don't think that it's in here. So if it is in here, I'll keep it. But yeah, it is. Okay, so we'll keep it. But we'll get rid of everything else here. And we'll go delete retain wires. Okay. And our smoothing is set to go fast. All right, this is what we have set here. I'm going to unlock it first, of course. It's an automation thing now. No. It's always properties. I can't remember what automation is. Smooth 30 milliseconds. Wow. Okay, so let's go 30 milliseconds then. All right. So that's center. And in fact, I might have to look at those, redoing those. And this goes to pitch. And what are the readouts here? So we have hertz for rate. Okay, and we're going to look at if there's any adjustments in there. For 12 volts, we have volt per kilohertz, but that's, I do believe that's just for a readout, I think. We have a float out. Everything's backwards, right? Yeah, so I do believe that's just for a readout. Here's our main controller here. So this is sort of irrelevant. Okay. What do we have here? Unit converter. Okay. Yeah, that's right. All right. So that's good. What is our range? So it's not running. I don't really want to turn it on. I think this is where we can look at automation, right? Where we want to run at automation. Okay, so negative 10.425. Negative low. Negative 10.425. And our high of 0.459. High of 0.459. It's quite a range. And our default is 0.459, so max, or negative 0.459 even. Okay. It just says 46. All right, and then we have phase, which is measured in degrees of a max of, I can't read that, 180. White on a gray background. Phase. Okay, 180. The default of 180. Of course, min is not required right now. Depth is measured in percent again, 0 to 100, with just a smoothing of the output. A float scalar multiplied by, so that's from text entry. So I do believe that is just scaling the readout here. That I want is automation. Yeah, it's just scaling the readout. So we want depth in percentage. I'm going to delete that. I'm going to grab center here, toss that there, and this is now depth. And 0 to 100. So we got two ways we can increase or decrease the value. However, we want our readout to be 0 to 100%. So what we have to do is decrease the value. Also, do we have a smoothing? We do. And of course, that's probably the super long smoothing, right? Yeah, 30 milliseconds. Okay. So we use math here and we'll scale it down. So math, multiply, and then we'll go by 0.1, right? 0.1, and that'll turn our 100 into 10. Just want to double check that. Times 0.1, yeah, max 10. Always double, triple check things. Before I move on, I'm going to save this as well. Okay, so that's phaser 1. And now edge is running. Why? Okay, so phaser 1 is saved. Now I'm going to fix depth, right? It's done. Good to go. Okay. So pitch, right? No, this is depth. So we want to use that on the level ADJ. As well, I was noticing earlier that this degree symbol is like super far out. This is just a side quick panel arrangement here. Let's see if we can get this in a little closer. Here, that's a bit better. How does that look with a weird number? Okay, so it doesn't give me any weird numbers. That fits, that looks good. Just a quick patch there. Percentage sign looks a little far too. That's fine. Because once it gets to the decibel, it kind of takes up that space. Milliseconds could probably be a little tighter too. Let's move it over 1. Looks like this is a little bit out of the way. Let's go move them over like 1, 2, 3, 4. 1, 2, 3, 4. And then this one, 1, 2, 3, 4. Okay. And of course, I didn't even need to do that because that's part of the current project. Okay, can I get the palette? This guy needs to come in 1. Okay, now do they look similar? Might have did that before I copied it. No, they don't look similar for some reason. What happened there? Let's try that. There. A little tight, but that's fine. Okay. Center depth. Now we plug the level ADJ into the depth, right? So the center with the pitch. Yeah. Okay. Just double checking from there to there to there. Okay. Looks right, feels right. Sure, it's pitch. It just feels weird to put that number into pitch. IO mod, we still never got any inputs happening, so let's get some inputs happening here. Input 1, input 2, and output 1, output 2. And we now need the stages readout here. So, of course, these have, limitations. This one has this just to keep it holding those specific waveforms. This one is all on its own, so let's use that one. And this is called stages, I believe. Yes. So we'll rename this stages. And we'll see how it looks. We'll line it up a little bit on the top end. We can get rid of min. Yeah. If I really need to rebuild one, I'll rebuild one. Tighten things up here, getting things look neater. This can also go. Hopefully we don't need it. Yeah. So this is the final result here. And that'll be phaser 1, I suppose. I feel like these are out of order as far as like what should be where. And it's also quite loose. If it's going to be loose, that's why I want to tighten it up. I almost want to crunch things in. Let's look at what the final result is here as far as GUI. Take a quick peek ahead. No, that's EQ. Okay, so it doesn't look like we get one. It's phaser variation 1. I guess we could look at this, right? But it's probably all just piled on top of itself, yeah. So let's take a peek at the later version. And of course, we're back here again. I'm not sure if it's still in my... Yeah, it is. Okay, and this is its own section, right? Phaser. Phaser 3 should be final and built. No save changes. Let's see what this looks like here. It's all just piled on. Okay. So let's just stick to what's here and we'll tighten it up a bit. And this will be phaser 1. And as usual, following how the book kind of does things, let's just over tighten things. That's kind of why I reeled in all of the contextual symbols so it looks a bit tighter. And we'll bring this in. Then we'll grab everything else, tighten up this edge. We'll leave like one piece of space, and we'll bring the preset manager in, just reeling things in here, nice and tight. There. Go ahead and save that. Actually, we'll get the preset happening first. Go phaser 1. The preset here is, of course, it looks awful. 0.17 hertz. Is it negative though? It just says positive. It doesn't even run at all. Okay, let's reload that. I'm pretty sure it was max. So I'm just going to put that max, which it is already. Remember it being max. And next up is depth, which is 46%, it looks like. It's so hard to read with the white on gray. Phase, I remember being 180, right? No, it says something else now. 86. It's so hard to read. 86%. It's phase, right? 360, yeah, capital 180. And then center, 57%. Default stages, max. So we're looking at 8 here. Okay, so now that's preset. Okay, so I'm not really going to be playing that. I'm not going to try it out yet. We can make it to like the third iteration of it first. Okay, so moving on through the book, progressing, we are at sort of this stage here. Swap. Okay, so page down, phaser variation 2. The above prefab simply notches the spectrum. They can't generate real feedback, but there are other ways to fake it. This example uses state variable filters to put notches and peaks in the spectrum, serving up a sound very much like a phaser. The trick is to subtract the high pass output from the state variable's low pass output, creating a resonant peak as well as a phase distortion. Then you route more of these filters in parallel. The phase cancellations create notches between the peaks as shown in figure 2.69. Great for simulating a phaser's whoosh. So figure 2.69, we see it just says peak, so there's probably filters inside there. An oscillator going into a level 80J. There's nothing else sort of modulating the 80J, and that's being fed into a signal. So I imagine this is some sort of a pulse wave or some sort of signature filling the frequency analyzer, which is also visible. And then we have three controls: pitch, resonance, and pitch again. Not sure why there's two pitches, but the frequency analyzer shows like a notch. It shows a full, it looks like a hill with like a hole in the top, a bit like a shallow volcano. And we can see that, well, it says that that's being created by, what is it? Subtracting a high pass from a low pass. So, yeah. Figure 2.7 pictures the peak container's plumbing, where the high pass out is subtracted from the low pass out. So figure 2.7, the peak's container internal structure, we see IO mod, signal pitch and resonance into a state variable filter, which has a low pass and a high pass, both running at the same time. And those are going into a subtract module. So the low pass is, or the high pass is the low pass is being subtracted from, the low pass is on top and the high pass is on the bottom. So the high pass is being subtracted from the low pass, and then it outputs to an IO mod. A switch similar to the previous prefabs determines the number of stages. Each container holds parallel peak filters as depicted in figure 2.71. The fixed value adds offset to the pitch, spreading the peaks in the frequency spectrum. The multiply module scales the output as the parallel filters boost the level. Okay, so I do believe it's talking about, 7.1, next page here. Okay, so I'm not sure what it's talking about. I believe it's talking about this one up here. Each container is depicted in 7.1. Let's see. A switch similar to the previous prefabs determines the number of stages. Each container holds parallel peak filters as depicted in figure 2.71. The fixed values adds offset to the pitch, spreading the peaks in the frequency spectrum. The multiply module scales the output as the parallel filters boost the levels. Okay, so I don't think it's actually pitch. Oh no, we have fixed values here. Okay, I thought that was a switch. But it did say something about a switch, did it not? No, it doesn't. Just imagining it. Okay. So this is inside of these. The external structure mirrors the previous prefabs, except that here a feedback's knob controls the filter resonance amount. Open the feedback's knob structure and you'll see how the subtract and level 80J modules shape the output signal. All they do is calculate 1 less bracket 1 less x bracket squared to change the resonance curve. Though it's not strictly necessary, this makes it easier to adjust the feedback amount. Figure 2.72 graph shows this curve for you. So we have a graph here, figure 2.72 resonance curve, and it shows a slope into, it shows an X sort of a favoring the plus values as it gets closer to the right. Starting at the left, we get a 0, 0 marker, and yeah, it's more leaning to the left, the curve. See phaser 3 for the full structure. This affects feedback emulation, sounds rather sweet. Note the notch's depth corresponds to the feedback amount. Okay, so heads up, state variable filters are all pole filters, meaning they boost high frequencies near Nyquist, possibly eliciting high frequency ringing. Prevent this by limiting the phaser's maximum pitch. Go to files phaser 3. Interesting. I never knew that. All pole filters, meaning they boost high frequencies near the Nyquist. That's visible in some of the tests I've been doing. However, I do believe that was rectified. As far as a roll-off, though. So the old way, it used to boost the high end a little bit, especially if you put them in serial. And the newer one, actually, it looks more like a high pass at the top. So it's kind of how you say EQ, squashing EQ crunch. Can't remember the technical term. However, it's avoided by oversampling. So you can avoid EQ crunch by oversampling, right? So my chair is rubbing up against the wall and it's making this annoying squeaking sound sort of thing. Can't predict everything that's going to happen in the live stream. I closed my windows. Getting kind of stuffy in here. Let me see what is next now. Okay, so let's build phaser 2 before moving on to phaser 3 and completing this. Save changes to phaser 1. No. Sorry, this can't be upgraded without the EVM phaser. Okay, so they're just using straight up phaser, it seems like. I was sure that these modules were installed though. But I mean, if it's just the phaser, then there's not really much going on there. So let's jump right to 3. So it would pretty much just be everything removed except for like a phaser preset, or a phaser module. It looks like we have a level ADJ now. We have a gainer, the 2 channels. We also have a waveform control now, which I, of course, dropped, right? And we have just those 3 against. Okay, so it was sort of a bad idea to drop that. I can bring it in. Of course, this is called course still. So let's go ahead and rename this to phaser. All right, and through the magic of video editing, it's instantaneous for YouTube. I'm going to jump into the chorus here, and we're going to grab this container. This is our waveform control. I had a suspicion that I'd be needing it. However, I didn't want it to really get in the way of the overlooking. So I do believe phaser 2 is just the EVM phaser. Let's call this 3. Oh, I hope that was saved that in the right spot. Which isn't really much of a learning experience or very... I mean, it's probably really good and saves on CPU and stuff. However, it's not really what this is about. Okay, so this is phaser 3 now. We now can have ability to control the waveform. And it's limited to just these 3. Oops. All right, I just want to see. Of course, if you double click too fast, it opens the box, right? Sine, sol, ramp, triangle. Sine. Okay. Now, let me bring in this level ADJ. Is there any other changes, really? I don't think it really mentioned any other changes. Oh yeah, everything's completely changed. It now uses... Okay, I gotta unlock that first. It now uses... Gotta unlock that one. A state variable filter. Okay. Now, I'm not 100% sure which state variable filter I prefer to use. Like it said, it boosts in the high end. And I don't want to use this one because it's kind of greedy, right? Because it's running all 4 of these filters at once. However, more modules, more load time. So we're kind of trading between load time and CPU usage. In this case, following the book, we're going to go with the older state variable filter, which likely boosts the high end. However, it's not that big of a deal. Like it said, limit the filter. So here's state variable filter 2. And as we see, it has only 1 at a time. It also has a strength. So, as I said, to keep in with the book here, we'll use the classic one here. And I do believe this, like it says, this is the one that boosts. So this must be the one that rolls off here. And if we look, I think it's called state variable 3, 4. Okay, so this must be state variable 3 then. Not sure exactly which one I prefer. Oops, not help. 2. So I don't know where 3 went then. Irrelevant. We're using this one. It does eat a little more CPU, but it loads faster. And what I prefer is things that load faster, because when I'm in a creative mood, I want things to happen. Opposed to, worrying about CPU load. You can always bake things, or I say burn or bounce tracks to regain CPU, but you can't recover your load time. Okay, so we want to subtract here. We're just going to build it here. Subtract, and then we want to subtract the high pass from the low pass. And we'll containerize that now. Head in there. And we'll look at the upper layer here. So this is called a peak container. And we have signal pitch resonance. And output. Okay. Wasn't there a fixed value here? No. Got a fixed value here of 2. Okay. So let's go ahead and copy this over. And we go controls, fixed value somewhere. Volts. And that is of 2. Are they just both called peak? Yes. Okay, and then we head up another layer here. This is called phaser 2. Okay. So let's make sure we get this right, as I made a mistake before of having a string value in there, or a ASCII character. But now it is definitely 2. I'm just going to double check that. Indeed. Okay, and this gets containerized, right? And that's called phaser 2. So we'll go containerize. And again, we're going to start building our input-output stuff here. Signal pitch resonance. And again. Okay. And that just goes straight up. Both to the same one. And that's our new phaser algorithm, opposed to the 2 all pass. I almost want to build like a phaser B, right? So I'm going to do that. I'm going to drop this here. And we'll continue along with what else is happening here, because we have this adjustment, right? Level ADJ, channel 1, channel 2, level adjuster. So this is probably just, level adjuster. And of course, we have dB to volts. So we don't have a converter to dB to volts. What I did in the past was a percentage, right? So let me look. I can't even remember what section that was in. Of course, we're doing a quick dig. Much prefer not to show the innards of my computer, but there they are. Let's check out the reverb. I think it was on the reverb. Level ADJ. And then this is just by percentage. Why is it a wet though? Isn't it just an adjustment? Wet and dry, okay. So yeah, it's a double signal, it's a parallel signal. And then that's all I did was 0 to 100%. So we'll do that, and this will be called phaser 1B because it has the adjustment. And that's it, really. I feel like we have one more knob here. Feedback into resonant. Interesting. I do remember it mentioning that. Okay. Let's look at that again. Open the feedbacks knob structure and you'll see how subtract and level AGA modules shape the output signal. Okay. The internal structure mirrors the previous prefab, except that here there's a feedback knob, controls the filter's resonance amount. This affects feedback emulation. Sounds rather sweet. Okay, so what that's doing is boosting right at the Q, right? So I'm not sure how well I guess that would be feedback, right? Because you're layering the same signal on top of itself again and again. So if we're kind of boosting, you know, that indifference between the signal, then it's pretty much feedback. However, in phaser 1, we do not have feedback. Okay, and what we want to do here is a level 80J. Quickly put that here. Where is that lined? Right at the output. So let's bring in a new container. Go left in, right in. Drop these. What is this called here? Input 1, input 2. Input 2. If it's just gain, like there's no wet dry or anything, it's just pretty much a gainer. Okay, and then level. We'll build a new knob here. Call it gain. There's nothing special about this knob. It's just a percentage gain. It's got a little bit of smoothing. Oops. What is this called? Level. Level in dB, however, level in percent, right? So we're not actually going to put any value. Just going to say level percent. And then we want our outputs. And again, this is just a level 80J. 0 to 10. So that's under modifiers. We have to have 2 because it's a separate signal. We don't want to mix our left and right. And then we have an output and left and right. And we'll just tidy it up a bit. Okay. So it's done. And what are the outputs called? Output 1, 2. Straightforward. We're going to add a space, however, and then output 1, output 2. I almost want to name them left and right. We'll name this left and right, just so that's what the DAW sees. Okay, same with over here. The inputs will be left and right. You can call them channel 1 and 2 like this, but no. All right, so that is needing to be fixed up here. We got 2 centers. Why do we have 2 centers? And gain. I got a duplicate center, right? Yeah. Okay. So we can just get rid of that and make double checking that this isn't adjusted anyway. Okay, so let's bring in the center here. We'll keep all the knobs. We also have oscillator waveform. That wasn't part of part 1 though, was it? Well, it's 2 different algorithms. I'm not sure how to break this down really, because now I'm sort of making my own spin on these things, and I was really hoping to stick to the book, right? So perhaps I'll just leave phaser 1 as is. It just kind of super blank. It doesn't even have waveform control. But 1, 2, 1B rather will have, you know, waveform control. Whatever. Yeah. Moving along, let's pull this ahead here. this here, this there. Of course, we can't read that. Let's like this. Throw gain in there. Nice and tight. This over. Let's put stages on the bottom. And of course, it looks funny because, yeah, the GUI is not quite as great as I'd want it to be. Like, it just, you can't differentiate where the arrows and stuff, which arrows for what. The title doesn't look good. There could be a little bit more GUI development there. What is there? It works. It looks like a rack or like a guitar thing. Guitar rack or rack. So it doesn't have to be specifically for guitar. So that's done. This is the older algorithm. This is 1B. Okay, so we'll go ahead and save that. Get rid of this. Actually, we're going to cut this. Quickly save. And then what we're going to do is drop that right back in. This is our new algorithm. If it will let me cut it. No. Right click, cut. Okay. Hit in here, and now we'll replace our older algorithm with our newer algorithm. However, I don't want to accidentally save over anything. So let's go phaser 3 and save. Yes. And now I can start bringing these in. This is phaser 2. Okay, so that's 2. What does it look like here? Phaser 3, channel 1. Phaser 2, it has those two. And then what is phaser 6? Look, is it 6? Let's lock this one and get it out of the way. No. Okay, it's phaser 4. 4? 2, 4. Where'd 6 go? There just isn't a 6? Really? Why did they pull 6? I'm in the wrong category. I can reload, I guess. Save changes. No. Right, there's a 6 there. Yeah, there's a 6 there. Okay. So following the prefab, I guess we're not going to have a 6. And then what does this look like internally? That's why I was kind of questioning is, what does phaser 4 look like? Okay, 1, 2, 3. And what does 8 look like? Whoa. No wonder there's no 6. And we could split hairs and do 3s and stuff, like 0.333, 0.666, 0.999. Like I said, we'll just follow the prefab here. We also have a multiplier. There's a lot going on here. Okay. 2, 4. So isn't this just that then? Why did it have me build a box? Okay. I'm just going to have to completely rebuild this. It'd just be faster. So let's go container. This is called channel 1. Yep. Otherwise, I'd have to unplug wires and replug wires, and it's easier to just throw this in here and patch things in. So this is phaser 2. Right, see, that's much faster. Let's call this phaser 2. Then we'll have our out mod. Then we have phaser 4. I'll copy that. Oops, didn't want to maximize that. I want to copy it. Yep. Well, then unhighlight that. Paste phaser 4. And then get in here. Drop 2 more. And we're going to split these differently as it showed on the previous panel. I don't know why things aren't snapping the grid. Again, we can actually just speed this up by containerizing this. Oops, I don't want to do that. I'm going to have to recontain. Okay, so let's do that again and delete this. Because I didn't want to uncontainerize that. If I recontainerize it, it's going to mess up all the pins all over the place. Okay, so more containerize. And then we copy this and we reroute this, and that saves us like double the patching. Oops. If I, stay efficient. Human error here. Okay, and then oath. And then these are parallel, right? Let's uncontainerize. And I forgot about my fixed value there. So now I'm going to have two of them. Yeah. But these are parallel. Yes, they're parallel. Okay. Opposed to the other one, which was the all pass was serial, I remember. Okay. No, this is just... I don't know. My brain is getting a little carried away with guessing something that is irrelevant. It's quizzing on the structure of the all pass type when it's irrelevant. What is relevant is doing this. Okay, so those are all in. This is renumbered. Of course, it has to reload. I'll force the reload by dropping an empty container just to see it, which is there. These are all plugged in. Isn't there like one more thing though? No, because that's why I rebuilt it, so I wouldn't have to unplug and replug things for resonance specifically. Okay, so now we want phaser 8. And that's 2 of these. So let's copy that again, drop that. And in here, containerize this. This time, I'm going to keep that fixed value on the outside. Go ahead and paste. Of course, it doesn't matter though. And I did that wrong. Because I'm still going to have to plug them anyway. So we'll go containerize selection. Is that going to give me an extra pin though? It does. Okay. That's fine. No big deal. Those have to be unplugged anything, and everything is going to be unwrapped again anyway. So pitch, the idea here is to reduce the amount of patching required. Okay. So we'll go ahead and unwrap that. Or containerize it again. Right? And unwrap it again. Okay. So now we have 4. And then we uncontainerize this, specifically uncontainerize. Okay, now we have 8. And again, they're all in parallel. So let's head into here, phaser 8s, and we got this mess of stuff here. But we go in 0.5s up to 3.5. So let's go ahead and start patching in pitches. First one is ignored, so there'll be 7 values, right? 3, 7, yep. Actually, we'll move this over here just so I can get a better view of these patches. And then we'll redo these numbers. And this is 0.5, tab 0.5, delete, shift tab down, tab 1, shift tab down, shift end, delete, I don't know why, 1.5, tab 1.5, delete, shift tab down, tab, this is shift end 2, tab 2, delete, shift tab down, tab, shift end, 2.5, tab, 2.5, delete, shift tab down, tab, shift end, 3, tab, 3, delete, shift tab down, just tab, shift end, 3.5, tab, 3 point. Shift tab, enter. It used to be faster in SynthEdit 1.1. We could just tab straight through everything. However, tabbing past the end parameter now sends us somewhere weird. Like we end up over here somewhere. I don't know where I am anymore. So anyway, it's as fast as I can get it. If I didn't have to talk while doing that, I would probably be faster. But I feel like the documentation would benefit from me documenting how to quickly do things. And I'm just getting things lined up again as I've lost my grid snap. Let's make things neat and tidy. Drop this over here like this. Zoom out and let's line things up like this and like this. No real reason, it just keeps things clean. I mean, it looks a little confusing. However, it's easier on the computer. It doesn't have to draw as much. Draw as many lines. Okay, so that's done. Now we are now, it's phaser, 4, right? This is phaser 4. And this is phaser 8. Okay, and now we want our switch. We want a level ADG over here. We have a choice. Yes, I do believe we want to switch now. Because this is channel 1, right? Yeah. No, it's over here. Okay. So then, what does this look like up here? It's a little messy, so we're just going to tidy that up a bit with our schematic. We can close this reverb now, no save. And then we're going to bring in a switch 1-to-many under input output, no, flow control 1-to-many. We'll drop these pins. No, we won't drop those pins. Choice, and this is stages. We're going to rename that now. And then our input. All right, input. Yeah. So let's override this input here. It should hold its pin, right? Okay. So we'll delete that. Actually, we'll plug this one in first because that pin is going to disappear if I do that. What are they called here? Input. Okay, so I got signal everywhere. I'm not going to be renaming all those. Maybe I can just for completionists. And then we'll do this first. That's not going to drop its pin, so I don't know what I did. But we're going to rename these real quick. Just going to use the mouse, no shift tabbing around. Be faster. I know it could shift tab between things anyway. Okay. And start dropping pins like this. Of course, the outputs. Oh, wait, we need a level adjuster, right? This is different. A little different. This is 2, 4, 8. 4 and 8. Where's my stages? And then these are the outputs. 2, 4, and 8. Of course, they all have the same destination. Output. So that's what I need, those level ADJs here. Okay, so modifier. Was it level ADJ? Multiply. Multiply. Math. Multiply. And there's 2, right? 1 for each channel, 1 for the outputs. Just the bottom 2 get a multiply. So it's shrinking the signal, it looks like. Okay. So that's what we're doing apparently, is shrinking the signal. It probably grew with the more phasers. And then these all go out. Rather with the EQs, right? Because it's stacking the EQs. So it's multiplying the signal. And we want to bring that multiply down. We don't actually need a fixed value, do we? We can just go 0.5 here. And that'll save us a module. Okay. Actually, this is 0.25. And that's chopping the signal into a quarter. And so like a 6 would need a 0.33, I imagine. 0.3 continued. All right. Nearing the end here. So that's channel done. And choice stages. We just need to do some reconnecting here. Perhaps I can containerize this, or yeah, I don't really need to. I can just cut this, jump in here, and drop that, and then do the input thing, pitch, resonance is irrelevant, stages. I'm surprised stages let me connect because they're not the same. Then I can delete all this, and then I can just unwrap that, right? and then I retain my pins without having to do a bunch of correction. The only thing that's missing is the resonance. And we'll do that again here. This will be called channel 2. And then we'll do some connecting, pitch. Resonance is irrelevant or not applicable right now. See, this one says like, why are you trying to connect this? Okay, I don't know why it let me in the other one. I think it was just spacing out for a second. Snuck one by the system. Maybe it wasn't connected. I gotta look at that. That's a little scary. Oh no, I totally dropped it, right? Genius, man. Okay, so let's just do the output here. At least we got most of the pins. Unwrap this. And continue. Oops, I still got these old ones in here. Let's get rid of this old one. And then I'm going to connect our stages. Okay, and it should update. No update. Oops. 2, 4, 8. Okay. So I'm going to give that a quick save. And then I'm going to open this previous one because I'm not sure why it let me connect the stages pin. It should not have let me. Is this connected? It is. I'm not sure what happened there. I can actually export this now. This is ready to go. I'll go with this one in the demonstration. There's no use in going back to phaser 1 standard because it has less controls. We're going to be directly comparing the algorithms here. However, I do require output here. Well, it says -10. However, I want full signal. So let's just go full signal here as a default. And then we'll save and we'll export this. We'll call this phaser 1. So 1. And actually, we'll name it more. We'll name it more relative. These are all pass. More relative to its algorithm. This will just be PA, I guess. Okay, save first, sure. While that's building, let's head back here, finalize this. Stages is in, everything's in. Okay, we need a resonance knob now. This is also called feedback, which is also a percentage, and it's likely just a drop in number, right? Whoa. There's a lot going on there. But it did explain it. So it looks like it's also like square rooting it or something, or exponentialing it. And it's adjusting by itself. I'm pretty sure level adjust is the same as multiply. So I think it's square rooting or it's exponentializing it. Itself by itself, right? It times itself. Okay. So subtract. Let's start building this chain here. This is called feedback. Jump in here. Is there a zipper or a smoothing? There is. Okay. So let's move this over here. And we had subtract. Subtract twice. Yes, subtract twice with a level ATJ in the middle. And this is adjusting by itself or multiplying by itself, I'm sure. Actually, I'm not 100% sure. Let's go properties. So our top number is 10. So we're times 10 subtract. So our signal subtract 10, subtract our signal, and then it multiplies by itself. And then actually, I don't know if that's multiplied. Sure, it's multiplied. And then again, 10 subtract our signal. And then my screen is run off on its own. Let's go back over here. The wonderful, what's it called? UI of SynthEdit. The lifestyle of SynthEdit. Constantly chase windows and have things go off on their own. Okay, so that's done. This is called feedback. Feedback. Okay. This gets plugged into resonance. Is it named resonance here? It is not. Okay, that's fine. And of course, this is all just in one pile, right? Yeah. Okay. So where do we want feedback? Put it before gain. We'll just stack things consecutively in order. I'm not really going to think about the logic of how things should go. What's our default feedback, I wonder? Nice and tight there. Default feedback is 99.6. It is 99.6. Okay, so let's go 99.6. That's a lot of feedback. And then we'll bring this over. So it's going to be like super resonating. It's like super, that's really lots of resonance. Let's click this. No, click this. Oh, come on. Bring it forward if ever I can get a handle of the handle. Get a hold of the handle. Okay. And then it's over. Bring this in. One thing I wasn't doing, I noticed, is my... Oh, it's in the same spot. So I guess we're back to the original size. But yeah, last one I didn't put that in the middle. So maybe I can quickly swing over here. And we'll edit. And we'll just stick this in the middle. Save and build. Build it again. Okay, just I'll get FL Studio open here, 21. It's going to take probably a year to scan for it. And I got this giant space here. Okay, save file, sure. It's building again. Phaser 3. So that's ready to go as far as I know. Then, yeah. Let's go export. This is phaser. What is it called? State variable or EQ? What do we call it? Notch and peaks? Notch peaks? Resonant? Let's call it EQ. Is it EQ though? When we say EQ, we talk everything. So let's call it filter. Phaser filter. Because it's just using 2 filters. And then this is phaser filters. F. And go ahead, save. Yes, and it's building. Let's head over to FL now. By the time I get there, those will be done building, and we're going to refresh. And we'll just review some of the ideas here. See, I don't know what this is, though. Parallel peak filters. I think that's just a demonstration. And there's our resonance. And it doesn't show us a picture of 2. And that's fine. It's just EVM. It's filter, I imagine. Okay, so it looks like this is going to take a while. All right. Through the magic of... Actually, I'll be over here again. No, let's just jump in. I'll cut this part later, perhaps for those watching the stream, if anybody. I'm going to make a dashboard here. There you go, controller. Control surface here. And then I'm going to bring in the new plugins here. New. Why do I have 2? Oh, because of the name. Let's go shell menu here, Windows shell menu. open. Is it going to open the file? Why did it? It's not what I wanted. Okay, where did it put that? Right on the master? Sure. Okay, so let's get rid of that. And I want to open the folder, not open parent folder. There we go. And then we're just going to get rid of that. Okay, so it's, yeah, that doesn't help. Delete that. I got to dig it out manually. It's really going to make me do that. All right, so let's dig deep into the computer. Let's see. Program files, common files. VST3. This is phaser. Phaser all past that one. Let's delete that. Yes. Okay, done. Now let's bring in these two here. What's the best way to do this? Probably on different channels, and then I could just click the light bulb. It's better than trying to click that little thing there. All right, so we have two all passes. I guess it's still filter based, right? An all pass is still filter based. There's even a resonance on all pass too. I just realized that. It's pretty much the same thing. Anyway, we'll find out. Let's bring in some knobs here. And this one's going to be called rate. Can I get on grid here? Rename this rate. And then we'll drop another one. This is depth. We'll go left, rather right. It's depth. We'll keep dropping them. So there might even be a phaser 1C. You know, it has a feedback. That's not today. Okay. And this is rename phase. Perhaps I'll just keep this in the final cut. I'll just like add a chapter so people can skip over it if they want. Then we'll go knob, default, name, this is center. And then, oops, spelling, CNTR. And last one, default, gain, rename gain. Perhaps for these stages too, no, because they're different, right? I can do the waveform, but I can't do the stages because they're different amounts. And even like a phaser 3 would be B with the 6-stage setup. Rename waveform. I'm not really sure how that's going to be controlled though, because yeah, I don't think that'll work. There's nothing to control. Can I turn that into a button? No, I'm totally bringing a new one. Okay, so let's go ahead and delete that. We'll go add button, default, it's a pretty big button, rename, and this is waveform. Stretch it out a bit so we can see the full name, snap it to grid. If it feels like snapping to grid, I don't know. Whatever. Go like that. No. Okay, now I'm just splitting hairs here. Isn't it the right size? Grid 10. There. That looks a little cleaner. Okay, turn that off. Now I gotta wiggle all these knobs. Okay, so that one, tools, last tweaked, link to controller, and then this is rate, except again here. Tools, link to control, last tweaked, link to controller. Rate. And now when we control this rate, they all get moved. So we'll keep that on max. Can I right click? No. So depth, option or tools last tweaked. This is depth at 46%. Depth, okay. Tools last tweaked. With the controller, depth. In fact, I remember there's a way to do like link all parameters, right? Okay, so this is center. Let's go center, accept depth, surface depth, gain, accept phase, accept rate is already there. Stages, why is that even there? I'll skip that. Waveform, this is a button, so we're gonna. Interesting that it lets me do that. I don't know. Let's leave that blank for now, and I want to see that again. Accept MIDI CC, and then can we just X that? Right. Now everything should be connected. Go 57%, I think. Center 57%. I gotta do it here. That's annoying. Phase 86-ish. Depth 19. That work? Okay. This is already connected. But this waveform here, can I get knob? Because it gave me the option to get the whole waveform instead of the button. I don't even know if the buttons can be. Okay, so I'll go rename waveform. And then steal that. And again, we'll do link all parameters. And we'll just go OK through most of them. Depth, gain, phase, rates, stages. We'll skip that. Waveform. Then we can connect to waveform. And then that's it. And then does this control? Oh, but it gives us all of them, eh? That's not good. Okay. Let's put that back to sign, and we'll just get rid of that. Delete, and then see if we can get this button here. And then tools, last tweaked is the button. It looks like it. Okay, accept, is it the button? No. Now it only gives us two options. So the button isn't a thing. I'll just have to do it manually, I guess. Or I could get the knob back and then just stick to the 3. Splitting hairs again. Let's go with the knob. And this is waveform. Okay. Then how do I do this? Link all parameters. And then accept, 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 accept. Skip. And this is waveform. Oops. Accept X. We do the same thing here. Link all parameters. Center is to center. Accept. Depth is already there. Feedback isn't a thing. Gain. Gain. Accept. Phase. Oops. Accept rate is rate. Stages isn't a thing. Waveform is waveform. Accept. Okay, so now when I make edits, I can control the values just right here. However, to keep things consistent, I have to set feedback here to 50% to make them exactly the same. And everything's kind of all over the place now. Okay, so let's just get them similar. So max rate, depth around 17%-ish, phase 86%-ish, center 57%-ish, gain, what was the gain? Gain is at, of course it's that, right? So let's go maximum gain-ish. Let's just turn that right up. Feedback isn't a thing, waveform, we'll keep it on sine for now. Okay, so let's get a guitar in. Actually, I'm going to throw up the BRB because I need like a chopping point, right? All right, so at this point, I have a dashboard controlling both of the phasers and I can directly compare them, their algorithms, and they sound at all much different. Accordingly, to make them similar, the feedback here has to sit at 50%. And I realized that all passes are actually made of filters too, so the all pass does in fact have a resonance spot. So there could be like this is the filter version. There could be a filter 1C, right? Because all passes do in fact have resonant. So back in here, as usual, I'm going to be demonstrating with a guitar, electric guitar. Alternative this time, let's go with, there's no real determination of what they are. Electric guitar big key switch. And then we'll get rid of these presets here. Give it a 100% clean sound. Whoa. That looked way too loud. Yeah, something's definitely broken somewhere. Let's turn this off. Is that coming through on stream? Yeah. All right, so something's broken. Let me look at the signal chain here. Input to the in, output to the out. Okay, so who is broken specifically? In fact, let's move these over. And then I'll send this to 1, and then I'll double chain it, right? So let's unplug it here, plug it there, and there. And we'll turn these on, but we'll kill this one. So is it the first one? First one is toast. Try the second one. Okay, something's wrong with the first one, which is here. So we get to enjoy some debugging. Maybe it's something with the settings. Okay, so let's bring this one back, open it up, and what exactly is wrong? Too much gain, maybe? Just turn the gain right off, flatline it. Yeah, so it's giving me nothing. Let's get 1%. So it's completely fizzling out here. Something is rocketing its value. 0.1 out of 10. Okay, so it's level 80J. That makes sense. Phase is there. The frequency is in. It has its adjuster there. Maybe here. But it's the same one as the second one. So, yeah, it's multiplying by 100. Then why is the second one still working? No, it's not multiplying by 100 because the knob itself has a... No, it doesn't. All right, so we need to bring in a math here and scale this 100 down. But it still should have worked. At 1%, then that would have been 10. Okay. The only thing I really see here, center is scaling down, and that isn't. Is it supposed to scale down? Center, of course, it's 100, right? So it's supposed to gain center. What is its range? 200. Scaling here. What is the final value? Oops, automation. 10. Okay, so yes, this is supposed to be scaling down. So let's get that scaling down as well. Again, it's still operable in the other version, so I'm not sure what's going on there. Okay, so that's repaired. 2 repairs. Let's check with our 2 repairs here. We'll go save or export, and it'll ask me to save. So, okay, save. I actually have to remove them first, right? I'm going to save the whole file here, because if I don't, create new project folder, desktop, project 1, we'll call this phaser testing. Because I got to remove them. However, if I remove them, I'll probably lose my links. So let's go ahead and close that. Then we'll head over here, save file first, yes. And we'll fix these ones. Small oversight, of course, following the book rate to the number and to the T isn't possible, as there's differences in the older version and the new version of SynthEdit. I mean, it might be possible, however, I prefer to just modernize it and do things my way. Just oversight because it wasn't part of the steps in the book. All right. There it is. There they are. Repairs are in. Let's go export VST. Phaser 3. Save file first, yes. This one's going to say okay. This one probably says okay. Let's reload FL, and we'll reload it with... Okay, it's not listed. Not sure why it's not listed. That was a decent save, decent shutdown. It should still be listed in its list. Yes. Okay, so phaser testing is here. Reloading everything. Control surface, controlling them. Let's test out this first one. Okay. Prepare your ears. Yep, still overloading. That's what you'd call an overload. What about number 2? Why does number 2 work fine? I can't hear anything. Like it's not doing anything. Quality content. So phaser 1B is our worst contender. Is it the level 80J? I don't think it is though. Input the inputs level to level, and that's coming out max 10. And it just goes ka-chunk. Depth here. Depth is scaled down. Phase doesn't need scaling. Rate doesn't need scaling. Rather, it's already scaled. Stages. Everything's running as expected. It's probably something simple. Weird though. Maybe I gotta reload them? I don't think so though. It should still be. So this one's getting no signal. Let's look at that. It's just passing a rate through. Is it a parallel? I don't think it's parallel. No, it's not parallel. It's in and then it gets modified and then it comes out. Is there something wrong with the modules I'm missing? Another good question is, are these oscillators sleeping? I had mentioned in the beginning, the oscillators wouldn't sleep. So let's open up the debug and let's run it. Oh. Okay, so there's something wrong with the audio driver as well. I can't check that. More likely than not, they're not sleeping. I'm not getting anywhere with my testing because there's only so much things to test, and they're all tested. And they all check out. Oh, there's no input. Wow. He's a plugin designer. And the signal's going, yeah, okay, so that's why there's a ka-chug. Okay, so this goes to pitch. What is this one? B. Inputs. So that's the problem there. That's why when I would hit the button, it would just go ka-chuk because it was sending a signal of 8. Okay, signal in. Again, I'm going to have to close FL Studio. Inputs in. Look at that, Another one. 4. And we could go back in the VOD and see the replay of my blunder. Wow. But that's, how you debug. Okay, I missed this one. All right. It still doesn't explain why the second one isn't getting any modulation at all. Maybe it's just passing right through. Okay, so that's all patched up. And I did fix the knobs. Again, this is documentation and not a tutorial. Okay. And right now I gotta close FL first. Okay, let's do that. Save changes, no reason to. And it's closed. We'll go build, save file, yes. Head over to the other one and see if that is the same problem. Okay, so we don't have any controls here. And yes, same thing. Wow. Okay, so let's rewire things properly. How is it still getting a signal though? Like, it's passing 8. And it's still making like a guitar sound. Okay, input. So it's coming to here. There was a switch. Okay, so the switch, that was right. I was thinking it was this. So I had it right the first time. Right? I was thinking something else. No? Totally messed it up. Okay, the signal's going through. Cut these. That's probably why the signal was going through in the other one. Because the signal gets passed here. But it's going to pitch in some situations. And pitch is going to pitch. Stage is going here. Okay, we'll put this. Okay. Yeah, no, I totally did that wrong. I had it right the first time. 4, 6. I was mixing things up in my head, thinking that these were fixed values, passing into the signal. Okay. But we do need the switch to pass the signal. Pitch, pitch out. Oops. Okay, so that's correct. So really with the more signal, it's just making a deeper notch. Wish I could hear it. Okay, and this is through. What does this look like here? No. Okay, so there's no adjustments here. And everything's running serial, no adjustments. Okay. Let's look at this again. And of course I did that wrong. Undoing and redoing everything I must do. Let's kill pitch and get resonance connected. But didn't this have like an adjustment? Resonance is there, pitch isn't there. Resonance here, pitch there. Didn't this have like a pre-adjustment? Oops. right? That's plugged in here. Okay, because that's plugged into there. And then I just needed I didn't use a fixed value because more modules means more load time. However, I just plugged it directly in, which is fine. Okay, so resonance and pitches are plugged in. Input is plugged in. Stages is plugged in. These have their small adjustment values. Okay. Again, pitch and resonance. Inputs to inputs. Adjustment values. What does it look like inside? Two, three. And yeah. Maybe I did have something wrong as far as me plugging things into the wrong spot, and I've just corrected everything. Hopefully, that looks right. Everything looks right here. I'll just not worry about lining things up. These are right. Everything looks right. These have been adjusted. So now that they have their control values, maybe they'll actually do something else. So let's get that built. Export, okay. Sure, save. I'm not sure if I exported this one, so let's re-export this. Okay, yes. Okay. And reload FL. Just now am I on? Hey, is it now on the list? No, it is not. Okay, so I'm gonna have to load FL first and then load that project. Okay, phase testing. These are built, right? Okay. All right, again, prepare your ears for the ka-chunk and ka-chunk. Does this one actually do anything? Yeah, there it goes. At least we got that one doing something. And let's pick a scale to mess around with. We'll go G, major, somewhere. Major. It's nice and low. Okay. It's really fast. So we're just left with this one going ka-chunk. Why does it go ka-chunk? I don't know. Perhaps it's something about the all passes, right? Because that's the only variable that's different. And as I said before, because the resonant is, increasing, like I've done tests on the all pass before and most of the filters, and just this amount of resonance still leaves a little bit of a bump. And when you compile that bump, you get sort of an increase in gain. So yeah, let's try with I wanted this one. However, let's try with a lower amount of stages here. And I imagine it shouldn't be as brutal if ever I can get it to click. Oh, those are bumping into each other. Great design. Okay, so as I suspected, that is the case. So it's a different algorithm. And if we do more stages, though, we're going to get more gain, right? Until the point where the gain is just flooding. Or maybe it's just 8? Is it just 8 that goes ka-chunk? Yeah, it's just 8 that goes ka-chunk. Okay, so there's something wrong with 8. Again, debugging, we've determined that. What is wrong with 8? Everything looks fine. Signal in. They're all in serial, right? It's just pitch passing. No, it actually looks like we're getting more signal. It looks like we're getting signal to pitch here. Okay, so I must have wired that improperly, which could explain why we're getting some sort of weird overload. Okay. Looks like we still got one signal to pitch. Okay. Exciting stuff. Let's go back here. Fix this one. Is this one? Yeah. This one also needs a repair. Or did I just go back into the same one? I just went back into the same one. Okay, so let's go to the bottom one. Jump on the phaser 8. And there it is. It's going to kill all these patches. So I'm definitely probably going to have, that doesn't make any sense. I'm definitely going to have to put some chapters on this video for YouTube. Otherwise, I'll get little haters in the comments as usual. When my content is subpar, people think they're showing up to a tutorial and then they get documentation. And that's why my channel doesn't have lots of views, which is fine. So yeah, that's done. I mean, I'd love to have Premiere content, but that costs more time, which means less videos. And less videos, it's not what I want. I'm not really a high-level production person, streamer, video maker. I'll save file first. Yes. I am do what I do and show it off. And if people like it, that's great. If they don't, they can go suck a lemon. But they do have the advantage of taking a learning experience from some of the stuff I do. All right, so now, again, prepare your ears for the ka-chunk, which is non-existent. So I was wrong about the resonant accumulating. It may be accumulating a little bit, but not to the point where it's super noticeable compared to. So we're coming in under 6, a little over 9. So we are getting a bit of a boost. As we can hear, this is a really fast rate. Okay, so here's the direct comparison. So we have the two phasers, one built with an all pass, one built with a, a high pass subtracting from a low pass, creating its own notch. And these are directly comparable with feedback at 50%. That's what the difference is besides the filter styles or the algorithm. And I have this control surface set up here to control them separately. So let's go through some of this stuff here. Looks like everything is comparable now. And I'll just drop a quick lick, or rather riff, as this is an electric guitar. Gonna tap in. Just what I'm feeling, and then we'll record something. Of course, we're in G major. I feel like my feet or my latency is really high, so let me turn that down so I get a little bit better of a response. So G major is a really more happier scale. Just do it right. Good. And it automatically quantizes itself, except I didn't get enough notes in there. Okay, so we're stepping up and then back down. Let's do it one more time. Not what I expected. Again, not enough notes. It's just too slow. So even though I tapped it out, let's bring it up to 100. Still Still not enough nodes. All right then, so let me just stretch this down. And then that. This, boom. So it looks like we're off time a little bit. Let's go ahead and quantize again. We will go quantize end time, quantize end time, and full go. Okay, so we're all over the place. What does that sound like? One more time. This time we'll just use chords and then I will drum them. What happened to my response? FL Studio's like, oh, I don't think so. Not today, buddy. Quality content. So the direct comparison will probably have to be a little bit later. Okay, let's just close it because it's not coming back online. And reload everything, and we'll get that riff in there right quick. Okay, so phase testing again, it'll reload everything up to the point where it was. The only thing missing is this riff. Let's close everything. And I guess I will reintroduce it. Nah. I want to call it a day, so we're just going to breeze through this. And I think I lost my G major. Eh? No, still got G major. But I'm not getting a response. Okay, because this is like down to 0, right? Let's crank that. Okay, so let's go like this. Whoa, that's way too fast. Why did that fit better? Just felt like it fit better. Okay, so let's bump this over a bit, and then we will go. Quantize, accept. I don't articulate. Oh, why is it out? Okay, and then what happened? These are off timing. Alt L. Okay. And then these are again off timing. Actually, I could probably use the quantizer, right? And go by bar or beats. Snap beats. Yeah, quantize end time. Of course, it didn't. Oh, because there was just that one. Okay, let's do that again. Then let's head in here. We'll grab these. And we'll strum. And then we'll reset this. We'll turn this off. Alternate direction time. Preserve end. Tension, no tension. Velocity, no velocity. We'll give it a bit of variable. Pull it in. No. Okay, so what are we looking at here? Okay, then I'll reel these in a third of a step, so we got a bit of space there. I don't like it. Again, I'm splitting hairs. Let's chop it a bit here. Under this, look like this. Not like that. We want perfectly on the beat. Stupid chopping. It just sounds too stiff. I apologize. This is supposed to be for SynthEdit, but yeah. No. Like this. Hopefully it starts in the right pattern. I don't think it's gonna, so whatever. Strum, alternate directions. Better than it was. Okay, so this is the point of the direct comparison. Two phasers, pretty much exactly the same, different algorithms. They're comparable as feedback's 50% matches what's inside the all-pass based. This one is filter based. All passes are filters. It's just a different algorithm. All right, so let's listen now. Just a really quick riff. It's a little loud for me. That's even louder. So now let's mess about with rate here. This is the first one. Doesn't even seem to be doing anything. Move the center a bit. It's like not even responding at all. Waveform. Depth. There we go. So I'm gonna change the rate now. Sounds like there's like a bird flapping around or something. No, less depth. The max depth. Wow. It's like a helicopter. Ooh. Wow. Okay, so let's look at the other version here. It's a bit cleaner. Much cleaner, in fact. Is the rate gonna respond? Rate doesn't seem to want to respond for some reason. So something is definitely broken with the rate. I did it as much as I thought it would be good. And yeah, it's just not. Hertz to octave, right? And then the oscillator is set 1 volts per octave. So no clue why it's totally crapping out. Like the rate doesn't even respond at all. I mean, these are really slow rates. It's negative, whatever, hertz or whatever. Maybe that's why, because it's hertz, right? So we're going into negative. And what does the preset say? It's probably why it doesn't move. It's changing itself, okay? So what is the final result here? I gotta turn it on. Not sure if it's gonna respond. Whoa. So that's what it's supposed to sound like. Totally brain frying. So it's 0 to 10, it looks like. I'm gonna restart it real quick. Yeah, 0.01 to 10. So that's where I kind of went wrong, was I converted a negative value here. Okay. So to repair that, we're going to go low 0.01 to 10 hertz. 10 hertz is quite fast. And then we'll rebuild it. Of course, I got to close FL again. Close somewhere. Save, yes. Even though my presets are now all over the place. Again, we are going to change this. 0 to 10. So again, a little bit of the discrepancy between the older version and the newer version, 0.01, right? 0.01 to 10, okay. And we're gonna build that. Save file first. Save file first, yes. Okay, again, my preset is a little broken, right? Because it's still a negative. It's still negative, so let's go 0.46 standard. And let's rebuild that file. Export it again because we want that preset in place. Save file, yes. Over here, bouncing around like a madman. 0.46. And export VST, save, yes. Okay, now I have to reload FL. Wow, lots of overloads. Lots of blenders. I don't think I've ever had a SynthEdit documentation. Well, not documentation, but the VSTI programming book goes so sideways. And they're still set to that. So is it 4.6, right? 4.46. What are the defaults here? So the defaults back in 4.6. 8657, 46, 86, 7, 46, 86, and 57. And 46, 86, 57. All right, again, after a bunch of fighting, this is the direct comparison. Lots of bugs happened, just kind of flowing from an older version of SynthEdit to the newer version of SynthEdit, and a lot of discrepancies, some oversights on my part. I didn't have a rate working, so this is, in fact, the direct comparison between the two algorithms. First algorithm being the all pass, the second one being two filters, the low pass, or the high pass subtracted from the low pass. And to make them comparable, feedback is set to 50, as the all pass doesn't have a feedback. It does have the function, but it wasn't included. So just a bit different. Also, there's only, there is 2, 4, 6, 8 stages here, and here there's only a 2, 4, and 8. So yeah, a little bit of a riff there. Starting with the first one here. Hopefully it doesn't go ka-chug. It's much smoother than I had it. Okay, so now we can fiddle with sound here. Turn it up, get a faster response. So there's that bird. It sounds like there's a bird in the air flapping around. Bring it back down. Actually, we'll keep it about 50 here. We'll get some wider depth. Ooh, super wide. And the bird's really flapping now. Okay, so bring this down here. I'm getting a really wishy-washy sound here with a really big depth, right? And it just travels all the way through the phase. Okay, bring this back down. Phase. It's just sort of the alignment of things. And of course, center will move it around, right? It's a bit more on the lower end. That's the high end. Actually, a little more depth. A little less depth. Let's bring us down here. High center, fast rate. Low center. Medium center. Let's change up the stages here. I'd rather waveforms. I get like a saw. Clicky, opposite of clicky. And triangle is the only other version that sounds really decent. Change the stages out a bit here. I got 2, 4. Gain. Slow, fast. Big depth. All right, and then we're going to switch to the other phaser. And we'll actually reset the values here as best as I can. We'll look at the preset here, 46, 46, 86. So 46, 46, 86. And a center of 57. I'm going to switch over to the alternative, would you say, algorithm? And we're going to switch back to sine wave. The warbly effect happening again. This is the alternate algorithm. Right away, it sounds a lot cleaner, I imagine. More phase, less phase, like no phase. So phaser isn't doing anything. It's just amplitude modulation at that point. So go about 90 degrees phase. I'll change the center, low center, mid center. I should be using these, right? Depth. Get the bird happening here. Ooh, that's actually a lot more amplitude modulation than the other one. At least that's what it feels like. Turn down the depth there. And here's feedback. This wasn't included. Actually, we'll go through the stages first. A little weaker. It's supposed to be weaker. It doesn't really sound like it. I don't really hear a difference. Stages. I think my stages button might be broken. Let's take a quick look at that. Okay. Stages are connected. And they are flowing through. And the signal is flowing through properly. Yeah, so it's connected. Just not making much of a difference, which is surprising. So let's get some feedback happening. It's a much deeper notch, right? So, whoa. Maybe now if stages will be affected. It's like a tremolo effect. It's something wrong with it, I think. But it is indeed moving. Interesting how it does that. And it goes too low. So I think what it's doing is it's stripping the sound at that point. Okay, so here's a direct comparison. We're going to send them both to alternating channels, left and right. I'm not sure how well that's going to pass through the stream or video. Here we go. Let's reset things here. What is it? 46, 46? 46, 46, 86, 57. 46. But we can't though, because it's a phase, it depends on stereo, right? Oh, it's going to be weird. Phase 57. Is it 86, 57, phase 86, 57. All right, let's click that. Yeah, it's totally broken. It's not even a thing. Take super phaser. And that'll burn us. Let's bring in the weird laser thing. So I got a bird shooting lasers now. All right, so that's pretty much the end of this. I might have watched something somewhere. I do feel like this felt more like amplitude modulation than it did stereo. So I might have botched something somewhere. If anybody is in chat, I will be answering any questions afterwards. And yeah, that's it for the phaser. That was the direct comparison between the two. It's built in the beginning. Quite a long session. Check out my website, jwpsite.com, for my social links, latest news and updates, and public offerings. If you'd like to help support what I do, check out my Patreon, JWP Patreon. That's with 2 Ps. There's exclusive content there from making your own audio plugins in SynthEdit, as well as the presets or prefabs for this specific SynthEdit visual documentation series. Or my GoFundMe, JWP Fund. If you're watching this on YouTube, like, comment, and or subscribe are appreciated. Thanks for watching. Until next time.